Welcome back, friends. In this class, I'll talk about the transformation of energy from one form to another. So we'll talk about transformation of energy from one form to another. So what does that mean? Let's say this is an inclined plane and the object is placed here. And if the object is placed here, this ball which I'm placed at a height of, let's say this is at a height of 20 meter with respect to the ground. So the total energy stored in this ball will be equal to potential energy. So potential energy will be equal to mgh. I'm gonna say, if that's, let's say the mass of the ball is 1 kg, so 1 times 9.81 times height is 20 meters. You're gonna get some value from here which will come out to be 196 joules if I'm not mistaken. So now this ball, if I starts rolling on this inclined plane, what's going to happen when this ball's going to roll on this inclined plane? That whole potential energy going to get converted into the kinetic energy. So now at this location, all the potential energy which was stored here will get converted into the kinetic energy, and there won't be any potential energy. So what will be the total kinetic energy at this location? Kinetic energy will be 196 joules. And keeping this thing in the mind, that we have to consider, if I'm considering that it was 196 and here it is 196, I have to also make sure that this plane is a frictionless plane. In reality, there is no as such thing, especially on earth, the frictionless surfaces, so some energy gets lost in the friction also. But here, just to understand the concept of transformation of energy, so that's why we are considering this surface as a frictionless surface. So whole of the potential energy got converted into the kinetic energy. Let's look at an example over here. So a man on the trampoline has a mass of 75 kgs. At first instance, he touches the surface and of the trampoline, and it is at the rest position, and he is descending with the speed of 8 meters per second. So this man is descending with the speed of 8 meters per second when he touches this trampoline. And then at his lowest point, the man is 0.65 meters above the trampoline under the rest condition. So as soon as he starts going in the downward direction after touching this trampoline, so he stretches this trampoline to a point 0.650 meters. So his energy, his kinetic energy, was stored in what form? His kinetic energy stored in the spring energy form. That's what it got stored into. So now let's try and solve this problem. So what is the kinetic energy of the man when he first comes in contact with the trampoline? So velocity is given to me, mass is given to me, mass equal to 75 kgs, and velocity is 8 meters per second. We can easily find kinetic energy. Kinetic energy will be half mv square, which will be equal to half times mass value is, the mass value in this question given to me is 75 times 8 square. So so total kinetic energy, EKE or kinetic energy, both are correct way of writing it, whatever way you like, you can write it that way, is equal to 2.40 times 10 raised to the power 3 joules. That's what you're gonna come across as. Now this whole kinetic energy, when he touches this, gets stored in the form of what? It's stored in the form of spring energy. And what it's asked me, if you assume that at its lowest point all of the man's kinetic energy is transformed into the elastic potential energy. So this, see, it's stating that we assume that at its lowest point all the man's kinetic energy is transformed into the elastic potential energy. So he's not talking about the losses. So what is the elastic constant of the trampoline? So I wanted to find the elastic constant. So I can say, first of all, EKE is equal to E spring. So spring energy is equal to the kinetic energy, because all the energies got transformed from kinetic to the spring energy, all of the man's energy. So I'm going to change the colors so that you can see it carefully, all the energy. Now this value will be equal to half mv square. Oops, we've already figured out, so I don't need to write it again. So it is 2.4 times 10 raised to the power 3, which is equal to spring energy, which is equal to half kx squared. All right, and then I wanted to find the spring constant k value. So x value is given to me. The trampoline moves to a distance of 0.650 meters. So k times 0.650 squared, 2.4 times 10 raised to the power 3. And then if I do the math, so this will go 2.4 times 10 raised to the power 3. So some students like to keep it as 0.5 half, so I'm going to use 0.5 right now, 0.5650 square, and then I can square this value and multiply with this value. So this will come across as, let me find my calculator, and where did the calculator go? Here, I'm using it on my phone. 0.5 times 0.650 times 0.650, that's gonna give me 0.21125k, and this is 2.4 times 10 raised to the power 3. When I'm gonna divide both sides by 0.21125, 0.21125, that's gonna give me the answer, and the value will come across as 1. So the value will come across as 1.14 times 10 raised to the power 4 Newton per meter equals to K. So hopefully you were able to understand this question. I'll see you in the next video. Bye now.